Alright, so third day of section 9.2, we're going to look at a little bit more with sums of sequences. Mostly we'll be looking at sums of arithmetic sequences, but we'll look at least one that's not arithmetic. So, but before we do that, let's take a look at a quick example, because one of the things that it's going to be important for you to be able to do is find out how many terms you're actually adding up. So let's say I had the sum as n goes from 1 to 5. Okay, and I want to figure out how many terms will you add. Okay, so we know we're going to plug in the number 1, we're going to plug in the number 2, we're going to plug in 1, 2, 3, 4, and 5. So we're going to see we're going to have 5 terms will be added. So let's make this part A. For part B, let's change it just a little bit. Let's say I have the sum as n goes from 0 to 5. So how many terms are we going to be adding for this one? Well, we're starting with 0 this time, so we're going to plug in 0, 1, 2, 3, 4, 5. So we're actually 1, 2, 3, 4, 5, 6. We're actually adding 6 terms. 6 terms will be added. So let's go back and let's take a look at how can I get this 5 from this 5 and this 1. Well, if I do 5 minus 1, that only gives me 4, but I can see that I have 5 terms. So let's add 1 back, and that will give me my 5. So let's keep that in mind. Over here, how can I get my 6 terms using my 0 and my 5? Well, let's subtract them again. If I do 5 minus 0, that gives me 5, but again, we just figured out that we have 6 terms, so I'll add 1 back. So that will give us our 6 terms. So let's take a look at one more example and let's apply this pattern that we just found. Let's say I have the sum as n goes from 10 to 35. Alright, and we want to figure out how many terms. Now, I'm not going to list out the numbers from 10 to 35 and add those up again, but I know that if I subtract these, 35 minus 10, that's going to give me one less term than I actually have, so I'm going to add 1 back to give me 26 terms that I'll be adding up. Alright, so this concept is going to be important because if we're not starting at 1, the number of terms that we need to be adding is going to be different than just subtracting these two. Alright, so if you remember from the last video, the one without the audio, to find the sum of an arithmetic sequence, okay, we're going to do s sub n is equal to n over 2 times a sub 1 plus a sub n. Okay, so n is how many terms we're adding up, so that would be the number that we figured out in each of the examples in the first part. A sub 1 is the first term, a sub n would be that last term that corresponds to the top number in the sigma. So it's important that you can only use this formula if the sequence is arithmetic. Okay, if you try and use this on something that's not arithmetic, you're going to get the wrong answer. So how are you going to figure out if the sequence that you have is arithmetic? Well, just check a few terms in the sequence. So check to make sure there is a common difference between terms. Okay, so figure out the first few terms, make sure that you're either adding the same thing each time to get to the next term or subtracting the same thing to get to the next term. Alright, so let's take a look at a few examples. So find each sum. And as always, if you feel like you want to give these a try on your own, pause the video, and then you can restart it to check your work. So we've got the sum as n goes from 1 to 50 of 1/2 n. So we need to make sure that this is an arithmetic sequence, so I'm going to figure out what the first few terms are. So a little scratch work on the side here. First few terms. Alright, so when I plug in 1, I'm going to get a half. When I plug in 2, I have a half times 2, so that's 1. When I plug in 3, I'm going to get 3 halves. When I plug in 4, I'm going to get 2. And you can see it's going to continue. So my common difference D is a half because we're going up by a half each time. So this one is, in fact, arithmetic. So I'm going to use S sub n is equal to n over 2 times a sub 1 plus a sub n. Right? And I know that my n, so it starts at 1, so I know there's going to be 50 terms, but just for the sake of consistency, I'm going to do 50 minus 1 plus 1, so that's 50. I know my first term, we figured that out over here, or you just substitute in 1, so it's a half times 1, so that's a half. And I need my 50th term, a sub 50, so it's a half times 50, or 25. Now that I have everything I need, I know that the sum of the first 50 terms is going to be 50 over 2 times the first term plus the last term, so it's a half plus 25. And if you plug all that into your calculator, right, you should get 637.5. Alright, let's try another one. Part B. We've got the sum as n goes from 5 to 7 of n squared plus 2. So if we take a look at the terms in this sequence, we're going to plug in 5, we're going to plug in 6, we're going to plug in 7. There's only 3 terms. So for this one, it doesn't matter whether you, if it is arithmetic, if you use the formula, but if it's not, then that formula is not going to work. So let's plug in 5 and see what we get. So 5 squared plus 2, and then let's plug in 6, so that's 6 squared plus 2, and let's plug in 7, that's 7 squared plus 2. So now I've got 25 plus 2 is 27, 36 plus 2 is 38, 49 plus 2 is 51. And if you take a look at the pattern here, for this one we're going up by 11, and for this one we're going up by 13. So since we don't have a common difference, we couldn't use our formula for an arithmetic sequence anyway. So we would have to figure this out. The only way we know how right now is to figure out each term and then add them. So this turned out to be 116. Alright, make sure you write down any questions and you ask them in class. Alright, part C. Let's say we have the sum as n goes from 10 to 115 of 3n minus 8. So let's take a look at the first few terms. So when I plug in 10, I'm going to have 30 minus 8, which is 22. When I plug in 11, I'm going to have 33 minus 8, which is 25. When I plug in 12, I'm going to have 36 minus 8, so that's 28. So we can see it's going up by 3 each time. So we do have an arithmetic sequence. Alright, so I need the number of terms, so n is going to be 115 minus 10 plus 1. So that's 110 plus 1 is 105 plus 1 is 106. And I need my first term, which is really a sub 10 in this case, because the first term is going to be plugging in 10. So that's going to be 3 times 10 minus 8. So that's going to give me 22. and I need my last term, so that's a sub 115, so that's 3 times 115 minus 8, and that is going to be 337. So I've got everything I need, so I know the sum of these 106 terms is going to be 106 over 2 times the first term in this sequence, which is a sub 10, which is 22, plus the last term, which is 337, and we should get 19,027. Alright, so that's it for this video. Again, write down any questions, make sure you ask me in class, and we'll see you soon.